Hi students, welcome back. We are here with another video. Let me quickly ask you a question. What is the formula for the capacitance of a capacitor? I didn't mean parallel plate capacitor. I just mean the capacitance of a capacitor. What's the formula? Q divided by V. What is Q? Q is charge on magnitude of the charge on any of the plates of the capacitor, or simply otherwise I can say it is the charge on the positive plate of the capacitor. And what is V? What is V? Potential difference between the plates of a capacitor. Remember that formula. It is the potential difference between the plates of a parallel plate capacitor. Now in today's discussion, we are going to consider capacitor with dielectric partially filled. In the last session, we have discussed about dielectric completely occupying the space between the plates of a capacitor. Now in this session, we are going to discuss about dielectric, which is partially filled between the plates of a capacitor. Okay, please consider the two plates of a charged capacitor such that the charge on this plate is plus Q, which will be distributed inside, and the charge on the other plate is minus Q here. Let the separation between the two plates of the capacitor is D. My first question is, what is the electrostatic field between the plates of this capacitor? What is the electrostatic field between the plates of this capacitor? You can write in your notebook. I hope you got the answer something like this. E is equal to sigma by epsilon 0. What is sigma? Sigma is equal to Q divided by A. Now this is a situation where there is no dielectric involved. Sigma is equal to Q by A, where A is the area of the plate. This is the formula for the charge density. Sigma is equal to. Therefore I can say the electric field E0, if I call it by E0, then E0 is equal to Q divided by A epsilon 0. We require it, so I keep it in a box. Now what is our discussion for today? Dielectric to be inserted partially, right? Let us consider it as another figure. The same plates, the same amount of charge. This is plus Q, this is minus Q. Okay, with your permission, I just wipe it off. I will write sigma is equal to Q by A here for your convenience. And what I say is this separation is D itself. I'm going to insert a dielectric which is partially between the plates of this capacitor. Then have the question to ask you, what is the electric field here? In terms of E0, you can say let the thickness of this dielectric be T. And the dielectric constant of the dielectric is K. So I want you to say, what is the electric field here? It's going to be E0. What will be the electric field here? It's going to be E0 itself. No doubt at all. No doubt at all. I hope it is clear. Now the important question coming. Important question. What is the electrostatic field inside a dielectric if the external field is E0? If the external field is E0, what is the electrostatic field inside a dielectric? If external field is E0. Yes. Just think about it. Think about it. Think about it. Or video. Two videos before that based on this topic, dielectrics and polarization. There you will find the answer. The net electrostatic field inside a dielectric. Yeah, it is E0 divided by K. Is it okay? Now my requirement is to find out the capacitance of this arrangement. Let me call this point as A. Let me call this point as B. I need to get the capacitance of this arrangement. The formula for the capacitance C is equal to Q divided by charge divided by potential difference between the two plates. So one plate is connected to the terminal A, second plate is connected to the terminal B. So I will say this is VA minus VB. This is the formula for the capacitance. Let me label it as equation number 1. Ready. Now the next job I am going to do is, I am going to call this point by the name, say D. And I am going to call this by the name F. I am not using C and E because E stands for electric field. This is D and F. Let us take this separation is equal to D1. This is D2. You can easily say that D1 plus D2 plus D is equal to D. Right? Okay, let us leave it there. Now, to complete this problem, I need the value of VA minus VB. That's what I'm going to find out. Please help me. VA minus VB is equal to, I'm going to write this in another way. This point is A and this point is B, right? Because they are joined by the same conductor. This may be written as VA minus VD plus VD minus VF plus VF minus VB. Am I right? Look at this. Minus VD plus VD. Minus VF plus VF. Okay. Now, let us consider the situation. I need the value of VA minus VD. We know the formula WAD divided by Q. We studied it in the beginning of this chapter. WAD by Q is equal to integral minus E dot dr, which is equal to VD minus VA, right? In this case, WAD means a charge Q is taken. 1 coulomb charge is taken from the point A to D. The direction of the electric field is likewise. The direction of the displacement is also likewise. That means the angle between E0 and D1 is, or E0 and D1 are parallel to each other, which means WAD by Q, or I will say VD minus VA is equal to the region between the plates. Electrostatic field is a constant. So that means I can take out of the integral, okay, minus E0 into, since the field is constant, the integral symbol can be avoided, minus E0 into D1, right? Electrostatic field is constant means no integration. Okay, let me explain it. I am keeping this integral. Minus E0 already we got a sigma by, or Q divided by A epsilon 0. Q divided by A epsilon 0 into displacement is D1. Angle between this one is 0 degree because E0 and D1 are parallel to each other. Is Q a constant? Q is a charge on the plate. It's a constant. Yeah, that is also a constant. Okay, I will say this is dr itself. Integral 0 to D1. Initial position is 0. Other distance is D1. That means I can say this is equal to minus Q divided by A epsilon 0 into cos 0 is 1. Integral dr is r within the limit 0 to d1. So this is d1 minus Q divided by A epsilon 0 into d1. But Q, okay, otherwise I will write this is E0 minus E0 minus E0 minus E0 into d1, which means I got VD minus VA is equal to minus E0 d1. What I want is VA minus VD, which is E0 into d1. VA minus VD minus VA is minus E0 D1. VD minus VA is minus E0 D1 means VA minus VD is E0 D1. Now see, now hereafter it's very simple job. VA minus VD. A is here, D is here, the region between A and D is having an electric field E0. Now tell me what will be VD minus VF. This is D, this is F. What is the electric field in the region between E0? Now it's very simple, as I told you. VA minus VD is equal to the electric field in that region into separation between the points A and D. Electric field in that region multiplied by separation between the 2 points, right? Now tell me what is VD minus VF? The electric field between D and F. What is that? Electric field between D and F. What is that? E0 by K into the separation between the points D and F. It is T. So E0 by K into T plus. The next thing is VF minus VB. Yes, come on. What is the separation between the points F and D? F and B. It is D2. What is the electric field between the points F and B? E0. Yes. Now I got VA minus VB is equal to this term. And from this one I can take common factor as E0. Then I will say this is D1 plus D2 plus T by K. D1 plus D2 plus T by K is E0. But already we wrote D1 plus D2 plus T is equal to D. Okay, again I am writing VA minus VB is equal to E0 is equal to Q divided by A epsilon 0, Q divided by A epsilon 0 into D1 plus D2 plus T is equal to D, which means D1 plus D2 is D minus T plus T by K. I got VA minus VB in terms of the non-variables. Here, what is A? A is the area of each plate of the capacitor. A is the area. A is the area of each plate of the capacitor. So VA minus VB is equal to Q divided by A epsilon 0 into D minus T plus T by K. And our equation for capacitance, what I want, C is equal to Q divided by VA minus VB, which implies capacitance C is equal to Q divided by VA minus VB, Q divided by VA minus VB, Q divided by VA minus VB, Q divided by, this will go to that side. This will give you the answer as epsilon 0 A divided by epsilon 0 A divided by epsilon 0 A divided by D minus T plus T by K. This is our final answer. Capacitance C is equal to epsilon 0 A divided by D minus T plus T by K. This is the capacitance when a dielectric is partially inserted between the plates or partially filled between the plates. C is equal to epsilon 0 A divided by D minus T plus T by K. This is the formula for the capacitance when a dielectric is partially inserted between the plates of a parallel plate capacitor. Hope it is clear to you. Now we are going to discuss the next topic. The next topic is capacitor with multiple dielectrics. Capacitor with multiple dielectrics. Okay, if the previous derivation is clear, then this is very easy to understand. Let me consider the plates of a parallel plate capacitor. This plate carries a charge plus Q, this plate carries a charge minus Q. Now I'm going to got more than one dielectric. For the moment I will restrict my discussion into two dielectrics. Consider one dielectric of constant K1 and the other dielectric. So I will put into mark to differentiate them. Dielectric constant is K2. Let the separation between the plates be D such that this separation is D1 and this separation is D2. One way you can solve is like we can consider them as two series combination, but let us follow the other method that we have learned. This is A and this is B. Let me call the intermediate point as D. First of all, we can write the formula for the capacitance of the combination. Capacitance is equal to what going to be? Q divided by VA minus VB. Just like in the previous discussion, our concentration will be on finding the value of VA minus VB. Right. Okay, so what's our next step? VA minus VB equal to VA minus VB is equal to VA minus VD plus VD minus VB. Let E0 is the field, external field. Let E0 be the external field. Then just like we wrote earlier, E0 should be Q divided by A epsilon 0. What I said E0? E0 should have been the field between the plates of the parallel plate capacitor if dielectric was not there. Dielectrics were not there. E0 would have been the field between, I repeat, E0 would have been the field between the plates of the parallel plate capacitor if dielectrics were not present. If dielectrics were absent, then E0 would have been the field between the plates. Now what will be the field between these plates now? It has got a dielectric K1, so this is E0 divided by K1 and this is E0 divided by K2. Now let's solve this. What is VA minus VD? VA minus VD. This point is going to be A. This point is going to be B. What is VA minus VD? VA minus VD. As I told you in the previous discussion, it's the product of electric field and the separation between the 2 points. Tell me, it's very simple. What is the electric field in the region between A and D? Question number 1. What is the electric field in the region between A and D? Very simple. It is E0 divided by K1. What is the separation between the points A and D? It's D1. E0 by K1 into D1 plus VD minus VB. You can find the point D here. You can find the point B here. What is the separation between the point? What is the electrostatic field in the region between D and B? Electrostatic field in the region between D and B. Yes. E0 divided by K2 into what is the separation between the points D and B? It is D2. Ready? Now I can say VA minus VB is equal to, I can take common factor E0. Along with taking in common factor, I am making the substitution also. Q divided by A epsilon 0 into, tell me what else, E0 is taken outside. This is D1 by K1 plus D2 divided by K2. And capacitance, what is the formula for the capacitance? C is equal to Q divided by VA minus VB. Now I got VA minus VB. Therefore, which gives me C is equal to Q divided by VA minus VB. I can take these terms to this side, this to other side. It's very simple now. Epsilon 0 A divided by D1 by K1 plus D2 divided by K2. This is the answer for the capacitance when two dielectrics are placed between the plates of a parallel plate capacitor. Now you can understand this in another way also. This is the answer we got. Now we are going to solve this in another way. You can treat this as one plate. This is the second plate. This is the third plate. The one end of the dielectric, the interface of the dielectric can be treated as a plate. In that situation, you can see that this is plate 1, this is plate 2. This forms a capacitor C1. Plate 1, 2, 3. The interface is considered as a plate of the capacitor. The interface is considered as a plate of the capacitor. This capacitance is now C1. This capacitance is now C2. Now see what is C1 is equal to. C1 is equal to K1 epsilon 0A divided by D1. C2 is equal to K2 epsilon 0A by D2. Then this arrangement is what type of arrangement? Series arrangement or parallel arrangement? It's series arrangement of capacitor. In that situation I can say 1 by C is equal to 1 by C1 plus 1 by C2. I got C1 here, I got C2 here. Substitute the values. I hope you will get this answer. 1 by C. Okay, let us prove it. This is equal to, in C1 and C2 you can find common what? Epsilon 0A. That means when you take 1 by C1, 1 by C2, this is this is D1 divided by epsilon 0A K1 plus D2 divided by epsilon 0A K2. This is 1 by C, or 1 by epsilon 0A into D1 by K1 plus D2 by K2. That will give you C is equal to the reciprocal of this term, that is epsilon 0A divided by D1 by K1 plus D2 by K2. This is the answer we got. This is the answer you are finding here also. This is how I can say the arrangement, series arrangements. I have taken two capacitors. Okay, now I am wiping it off. I just want this relation only. The same problem may be asked to find out the equivalent dielectric constant of the medium. Okay, that also I am going to do. That means, what do you mean by equivalent of the dielectric? So I want to replace these two dielectrics with a single dielectric so as to get the same effect. So as to get the same effect with these two. I repeat, replacing with an equivalent dielectric means, or in order to find the equivalent dielectric means, replacing these two dielectrics with that single dielectric, replacing these two dielectrics with that single dielectric which can provide the same effect as given by the combination of these two. Once more, equivalent dielectric is that single dielectric which can replace these two dielectrics still by providing the same effect. Still by providing the same effect. In that situation, I am replacing them with a single dielectric. Now the separation between, okay, I will draw in that situation, the figure will be, this whole separation will be D1 plus D2. Now I got a single dielectric that will replace their combination. Okay, this is just to differentiate only. That dielectric has effective dielectric constant K effective. In that situation, I will say capacitance C is equal to, this plate carries a plus Q charge, this carries a minus Q charge. The capacitance C is equal to K effective into epsilon 0A divided by D, 1 plus D2, right? K effective epsilon 0A divided by D1 plus D2, that is equal to epsilon 0A divided by D1 by K1 plus D2 by K2. epsilon 0 A can be cancelled. Now you'll get this answer as what? K effective divided by D1 plus D2 is equal to 1 divided by D1 by K1 plus D2 by K2. Or, okay, that's the thing I can say. This is the value of this thing. K effective divided by D1 plus D2 is equal to 1 divided by D1 by K1 plus D2 by K2. Okay, this is the answer we are getting. Hope it is clear. So if we have more dielectrics, then what will be the effective capacitance? C effective if more than 2 dielectrics. If more than 2 dielectrics are present, then what will be our answer? C effective will be equal to, or C is equal to, now we can directly write that equation. When we have 2 dielectrics, we got epsilon 0 A divided by D1 by K1 plus D2 by K2. If you have more dielectrics, then what would be our answer going to be? Plus etc. plus Dn divided by Kn. Okay, this is the answer we are getting if you have more than 2 dielectrics. But generally we are getting problems in such a way that D1 is equal to D2. The problems that we generally get is the separations are equal, the length of the dielectrics are equal. If D1 is equal to D2, then this formula can be written as K effective divided by 2D1, right? That is equal to 1 divided by D1 by K1 plus D1 is equal to D2, that is D1 again by K1, right? Now this can be written as 1 divided by, D1 can be taken common factor, D1 is common, taking LCM, this is K1 plus K2 divided by K1, K2, that K1, K2 I am taking to the numerator, which means I can cancel this 2, which means I will get K effective is equal to 2K1 K2 divided by K1 plus K2. This is effective dielectric constant when 2 different dielectrics having same thickness is inserted between the plates of a parallel plate capacitor. Same thickness is inserted between the plates of a parallel plate capacitor. Now you have to understand that this is series connection. So how do you know whether a combination is series or parallel? In series connection, you have to say the separation between the dielectrics are shared. Separation between the dielectrics are shared in series combination. Separation between the dielectrics are shared in series combination. You can see total separation D means one takes the separation D1, the other takes the separation D2. Now we are coming to the series combination is over. We will now discuss parallel combination. Parallel combination of dielectrics. Parallel combination. Now this is the arrangement. You can see one dielectric is placed like this. This is K1. The other dielectric is placed like this. This is K2. Now in this case, what is shared? You take the points as A and B. What is shared in this case? Both dielectrics have the same thickness, but the area of the plates are shared by 2 dielectrics. This means I can redraw this as something like this. This is C2. This is C1. This is filled with a dielectric of constant K1. This is filled with a dielectric of constant K2. In this case, I can say C effective is equal to C1 plus C2, This is the effective capacitance when capacitors are connected in parallel. Now what is C1? Okay, let us take this part of the area as A1, this part of the area as A2. C1 is equal to K1 epsilon 0 A1 divided by D, where D is the separation between the plates of this parallel plate capacitor. And C2 is K2 epsilon 0 A2 divided by D. Here in parallel combination of dielectrics, what is shared? Area of the plates are shared in parallel combination. In series combination, the separation between the plates are shared. Very, very important. In series combination, separation between the plates are shared. In parallel combination, area of the plates are shared. Now I can say this is equal to K1A1 plus K2A2 divided that into epsilon 0 divided by D. This is the effective capacitance in this arrangement. Just like the way we did earlier, we need to find out the effective dielectric constant. In that situation, I can use the idea. I am replacing these two with a single dielectric. Single dielectric. The total area here is, area of the plates here is A1 plus A2. In that situation, C is equal to, this is K effective. K effective into A1 plus A2. What is the separation between the plates? It is still D divided by D, right? Which will give you, comparing these two equations, this is equation number 1, this is equation number 2. So when you compare, the left sides of the equations 1 and 2 are just the same only. Now we have to say, okay, one more thing, there is another epsilon 0 coming. Epsilon 0 into A divided by D is the formula for capacitance. What I'm going to get, when you compare this side, that side, yes, what are common in both equations? Epsilon 0 by D is common in both equations. They will cancel out, which will give you K effective into A1 plus A2 is equal to, what I'm going to get, K1 A1 plus K2 A2. Or I can say K effective is equal to K1 A1 plus K2 A2 divided by A1 plus A2. Now you can guess the answer if you place n dielectrics in parallel. In that case, what will be K effective is equal to K1 A1 plus K2 A2 plus K3 A3 plus K4 A4 plus etc. plus Kn divided by A1 plus A2 plus A3 plus etc. plus An. Very simple. This is also an important formula. This is also an important formula. Now I can say, now you can find out if A1 is equal to A2, what is K effective is equal to. I leave this part of the problem to you. You need to find it out. I hope this idea is clear to you. Study these topics by today itself. You will find some questions of this kind in our NCERT book, but moreover it's an entrance-oriented method, entrance-oriented theory that can be asked for the board exam also. Based on today's discussion, you can try an example from NCERT book. Example, if my information is correct, it is example 2.8. Example 2.8, please try as a homework. Thank you. Have a good time.